For example C, we have tan of 2 alpha plus pi. So to do this one, we want to first of all recognize that we have a plus pi, and we need to use the identity for that. And then we also need to recognize we have a double angle here. So a couple things. So we want to, first of all, apply the tan identity. So the double angle, the sum identity for tan is going to be, okay, looking from my formula sheet, I'm going to end up with tan of 2 alpha plus tan pi. Do this in a different color. So tan pi, I already have. And in the denominator, we have 1 minus tan 2 alpha times tan pi. Okay, so that's our the sum identity. We still need to resolve this double angle, but to start with, we can work this out. And we end up with tan of pi, the slope is 0, so we end up with tan 2 alpha over 1, because tan 2 alpha times 0, so we're going to end up with this is equal to 0, and this is equal to 0, so we end up with just 1 in the denominator. Now, why is that the case? It's because no matter where we put the 2 alpha angle, so if I put the 2 alpha angle anywhere in this circle, so for example, I can put it here, there's my 2 alpha angle. If I add pi to it, I'm just going to end up on the other side of the circle with the exact same slope. Oops. Just make sure I get that the same slope here. So I end up with the same slope. So the tan of the plus pi position is going to have the exact same tan as the original position. So this is why when I apply the identity, I end up back at 2 alpha. Okay, so if you have that, if you can justify that geometrically, that would be perfectly fine, although we don't need to anymore because we can just use our identity to justify this. Okay, so I'm just going to put this off to the side. And then now I just have to worry about the 2 alpha. So the tan 2 alpha, I can just change this using the identity from my formula sheet. And the tan 2 alpha is going to end up being and again, I'm just going to get this from my formula sheet. Okay, so I end up with 2 tan alpha. Well, I have a picture for tan alpha over 1 minus tan alpha squared. And just whatever I get there, I'm going to square that. Okay, so then I go to my picture and I could just do my substitution. This becomes 2 times in my picture, my tan alpha is going to be root 40 over negative 3. Okay, and then in the denominator, I can replace the same thing. 1 minus, this is going to be root 40 over negative 3 all squared. Okay, so taking that expression, I'm going to end up with 2 root 40 and put the negative on top over 3. That's my numerator. In my denominator, I'm going to end up with 1 minus 40 over 9. Okay, so 1 minus 40 over 9. And simplifying this, negative 2 root 40 over 40 1 minus 40 over 9. So it's 9 over 9 minus 40 is going to be negative 31. Oops, I just need to fix that again. So this is going to be root 40 over 3. And in the main denominator, I'm going to end up with 31 negative over 9. Okay, so then simplifying this out, I'm going to end up with the negatives cancel. The 9 goes on top, so 18 root 40 over the 3 is divide, the 31 is divide, so it's going to be 3 times 31, or 93. So the slope that I'm going to end up with, or the tan ratio of 2 alpha plus pi, is going to be 18 root 40 over 93. If you want, you can leave it like that. We can factor out that square root 4 to become 36 root 10 over 93. Okay, so either answer is perfectly fine.